Welcome to Coding Patterns. We will talk about two pointers technique. This technique is powerful strategy for solving problems efficiently, especially arrays and linked list. So here how it works: you maintain two pointers, often starting from opposite ends or at a different speed. So let's dive into the quick Java example. So in this Java code, we use two pointers to efficiently find a pair of elements that sum up to the target value. So by leveraging this technique, we optimize our solution to achieve better time complexity. So whether you are working for arrays or linked list, remember the two pointers technique is a swift and elegant solution. Stay tuned for more. We are going to discuss island coding pattern. So this pattern is used when we are dealing with grid-like structure containing interconnected land masses known as island. Imagine a grid where 1 represents land and 0 represents water. An island is a group of adjacent land cells surrounded by water. So why this pattern is useful? Well, it's essential for various problems like finding the number of islands, determining the size of each island, or even finding the perimeter of island within a grid. So how does it work? We utilize techniques like DFS or BFS to traverse through the grid, identifying and marking land cells as we go. So let's dive into quick example in Java. So in this example, we will count the island in a grid structure. So whenever you are faced with problems involving grid traversal and island identification, remember this pattern for efficient solution. Unlocking the power of fast and slow pointers pattern. Whenever you need to detect cycles, find middle elements, or solve two pointers problem, this pattern is your go-to strategy. So how does it work? You maintain two pointers, one moving faster than other, to traverse the data structure efficiently, detecting patterns or reaching the desired outcome. So let's dive into quick example in Java. In this Java code, we use fast and slow pointers pattern to detect a cycle in a linked list efficiently. We initialize two pointers slow and fast, move them at a different speed. If there is a cycle, the fast pointer will eventually catch up with the slow pointers. Stay tuned. Let us discover sliding window pattern. Whenever you need to solve problems involving substring of subarray computations, this pattern comes to the rescue. How does it work? You maintain a window that slides across the array of the string, adjusting its size as needed to solve the problem at hand. We can discuss one quick example in Java. In this code, we use sliding window pattern to efficiently compute the maximum sum of subarray of size k in an array. We maintain two pointers, I, to iterate through the array, and window sum to keep track of sum. As we iterate through the array, we add elements to the window sum and slide the window forward. When the window size reaches k, we update the maximum sum and remove the first element of the window from the sum to slide the window. Let's dive into merge interval pattern. Whenever you are dealing with intervals and need to merge overlapping ones to simplify your data. So you sort the intervals by their start times and then merge overlapping intervals one by one. We can discuss a quick example in Java. In this Java code, we first sort the interval based on their start times, then merge them iteratively. By leveraging the merge interval pattern, we simplify our data by merging overlapping intervals into the larger one. So whenever you encounter problem involving a merging interval, remember this interval pattern for the straightforward and efficient solution. Stay tuned for more coding tips. Explore the cycle sort pattern, a unique approach to sort arrays that minimize the number of writes. So how does it work? You cycle through the array, placing each element in its correct position by swapping it with element at its sorted index. We can take a look at the Java example. We iterate through the array. For each cycle, We select the current element and find its correct position by counting the number of elements smaller than it. Then we swap the current element with the elements at its correct position if necessary and continue cycle until the current element is in correct position. This process repeats for each elements in the array, resulting in a sorted array with minimal writes. Let us discuss the in-place reversal of a linked list, a powerful technique for reversing the direction of a linked list without using additional memory. So how does it work? You traverse the linked list, reversing the direction of pointers as you go. Let us take a look into a quick example in Java. So we will store the next node, then we will reverse the current node's pointer and move pointers one position ahead. So by leveraging the in-place reversal of a linked list pattern, we reverse the order of elements in the linked list without using additional memory. Stay tuned for more coding tips. Let us discuss the BFS coding pattern. This pattern is a powerful strategy for traversing trees level by level, exploring all nodes at each level before moving to the next. So here how it works. We use a queue to keep track of nodes at each level, visiting them in a BFS manner. So in this Java code, we are using queue to traverse the tree level by level and store the nodes in list corresponding to each level. So whenever you need to traverse a tree level by level, remember the BFS technique for the efficient and straightforward solution. Stay tuned for more. Let's discuss DFS, depth first search coding pattern. We traverse as deep as possible along each branch before backtracking, or we use a stack to traverse the tree in the depth manner. Let us dive into quick Java example. So there are two different ways for DFS. One is the recursion, another is the stack. By leveraging the DFS technique, we efficiently traverse trees or graphs, exploring all nodes in a depth-first manner. So whenever you need to traverse a tree or a graph in a DFS manner, remember this DFS technique. Stay tuned for more coding tips. Happy coding. Welcome to Quick Coding Tips. Today we will discuss the two heap pattern. This pattern is a clever strategy for efficiently managing data by maintaining two heaps. Here's how it works. We use two heaps, one max heap and one min heap, to store and balance data as needed. Let us dive into a quick example in Java. So we have taken one max heap for smaller half of data and one min heap for larger half of data. So we use two heap pattern to efficiently find the median of a data stream by maintaining a balanced agreement of elements in two heaps. Let's discuss the subsets coding pattern. Whenever you need to explore all possible combinations of an elements within a set or array, you generate subsets recursively by including or excluding each element and ultimately producing all possible combinations. So in this Java code, we start with an empty subset and add it to the list of subsets. We iterate through the input array and generate subsets by including or excluding each element. We add each generated subset to the list of subsets. So whenever you need to explore all the possible combinations of elements within a set or array, remember this coding pattern. Stay tuned for. Let us explore the modified binary search pattern. It is a powerful technique for efficiently searching the sorted array or list with the variations. So how does it work? You apply binary search with tweaks to handle specific conditions or edge cases, such as finding specific targets or variations in the search criteria. In this Java code, we use modified binary search pattern to efficiently search for a target element in a rotated sorted array. We initialize the left and right pointers. For the binary search, we iterate through the array, updating the pointers based on the specific condition to handle variation in the search criteria. If found, we return the element, otherwise -1. Stay tuned for more coding tips. Let us explore the bitwise XOR pattern, a clever technique for solving various coding problems efficiently using bitwise XOR operations. Whenever you encounter problems involving finding unique elements, detecting anomalies, or solving challenges related to the parity. So you leverage the properties of bitwise XOR operation to manipulate and compare bits, often resulting in the elegant and efficient solutions. So in this Java code, we use bitwise XOR pattern to efficiently find the single unique number in array where all other number appear twice. Stay tuned for more coding tips. Let us explore the top k elements pattern, a smart strategy for efficiently finding the top k elements in a collection based on frequency or value. So how does it work? You use a data structures like heap, priority queues, or hash maps to track and retrieve the top k elements efficiently. Let's take a look into a Java code. First, we will count the frequency of each number and then use a min heap to keep track of top k elements by their frequencies. Then extract top k elements from the min heap and reverse the list to get elements in the descending order of frequency. Let us explore the Kway Merge pattern, a powerful technique for merging k sorted arrays efficiently into a single sorted array. So how does it work? We use a priority queue or a min heap to merge the elements from k sorted collections, ensuring the overall collection remain sorted. So let's take the Java example. In this, we use a min heap to keep track of smallest element from each array along with their array index and element index. Then add the first element from each array to the min heap and continuously extract the smallest element from the min heap and add it to the result list, while also adding the next element from the same array to the min heap if available. Let us discuss the topological sort, an algorithm for sorting vertices in a directed acyclic graph based on their dependencies. Whenever you need to order tasks or events with dependencies such as in project scheduling, task planning, or course prerequisites. So how does it work? We can use DFS or BFS algorithm to traverse the graph and order the vertices based on their dependencies. So in this Java code, we use topological sort algorithm to order the vertices in DAG. We initialize the graph and calculate the in degrees of each vertex. Then we find all sources with in degree of 0 and add them into a queue. Then perform topological sorting by repeatedly removing sources from the queue and updating their in degrees and adding new sources. We check for the cycles by comparing the number of sorted vertices with the total number of vertices. So let us explore the trie data structure, efficient tree-based data structure for storing and searching strings. It is used in scenarios like autocomplete, spell checking, or prefix-based searching. So how does it work? It is a tree-like structure where each node represents a single character of a string, and by storing prefixes as common paths, it enables efficient searching. So in Java code, we define a trie node class representing each node in a trie with a map of children and a flag indicating if it's the end of the word. And we define methods for insertion, searching, and prefix searching using the try structure. Stay tuned for more coding tips. Let's explore the backtracking pattern, a powerful technique for solving problems through systematic exploration of all possible solutions and backtracking when reaching dead ends. So, when should you use it? Whenever you encounter problems involving making a sequence of decisions to reach a solution, such as finding paths, permutations, or combinations. How does it work? You recursively explore all possible decisions and backtracking when necessary to try alternate paths until a solution is found. Let us take a look on the Java code. So in this, we use backtracking pattern to generate all permutations of a given array of integers. We explore all possible permutations by trying each element monotonic stack pattern, a technique for solving problems involving finding the next greater or smaller element in an array efficiently using monotonic stack. So how does it work? We use a monotonic stack to keep track of elements in a non-increasing or non-decreasing order and efficiently searching for the next greater or smaller element. So in this Java code, we use monotonic stack pattern to find the next greater element for each element in an array. We iterate through the array in reverse order and pushing elements onto the stack. Then pop elements from the stack until we find an element greater than the current element or until the stack is empty. Then we store the results accordingly. Dynamic programming. It is a powerful technique for solving complex problems by breaking them down into simpler subproblems and storing the solutions to avoid the redundant calculations. When you should use it? Whenever you encounter problems with overlapping subproblems and optimal substructure such as those involving optimization or counting. So we have taken one programming example to compute the nth Fibonacci number. So we create an array dp to store the solutions and we fill the array using the solutions for previously computed subproblems. Let us explore the multi-threading pattern, a technique for improving program performance by executing multiple tasks concurrently using threads. So how does it work? You create multiple threads to execute different tasks concurrently and allowing them for parallel execution to improve the performance. So in this Java code, we use multi-threading to execute two tasks concurrently using separate threads. Stay tuned for more coding tips. Happy coding. Let us explore the union find pattern. It is a powerful technique for efficiently maintaining disjoint sets and performing operations like union and find. Whenever you need to work with disjoint sets and perform operations like merging sets and finding the representative element of a set efficiently, we use this pattern. So how does it work? You represent each set as a tree-like data structure, where each node points to its parent. The find operation traverses the tree to find the representative element, while union operation merge two sets by attaching the root of one tree to the root of other. Here is the basic Java code. Stay tuned for more. Let us explore prefix sum pattern. It is a technique used to efficiently compute cumulative sums of elements in an array. So how does it work? You pre-compute prefix sums and store them in an array. Then to find the sum of elements within a range, you subtract the prefix sum of the starting index from the prefix sum of the ending index. So let's take a look on the Java example. So whenever you need to efficiently compute range sum in an array, remember this prefix pattern for a quick and optimized solution. Stay tuned for more coding tips. Let us explore the segment tree pattern, a data structure used to efficiently perform range queries and update an elements in an array. So whenever you need to efficiently compute range queries like sum, minimum, maximum, or any other associative operation over a range of elements in an array, we can use segment tree. So how it works? You represent an array as a binary tree where each node represents a range of elements. Each node stores the result of the operation over its range. The update and queries can be performed efficiently by traversing the tree. So here is the Java example. Stay tuned for